Welcome, ladies and gentlemen, to Knight's Notes number 2. We're at Chapter 1, Lesson 5. We are graphing proportional relationships. Get your notebook set up, and let's begin. So first off, we need to go through just some recapping of what graphing looks like. So first off, this is the first thing I need you to jot down in your notes because you'll see our symbols up here. And first we're going to turn your attention to this section. This is what's called an ordered pair. An ordered pair gives you two directions about what's expected when you are graphing. Gives you kind of those instructions about how to get to that one specific point. So in every ordered pair you're given two locations, an x coordinate which comes first, a y coordinate which comes second. Think the alphabet. X comes before y, x is always first. And how this works, just to recap we have ourselves a graph here. Here I'm pointing to the y coordinate. The y coordinate is the vertical one. Y to the sky always helps me think those. The y points towards the sky. That's always your vertical axis. Then you have your x axis. X kind of is that short and fat kind of letter, and it looks like it's kind of running along the ground. If you can imagine these two as little legs down here running across this flat ground, we have x always as the horizontal axis. So if I'm giving you this ordered pair of 2, 10, what I'm hoping that you do is you first start with the x ordered pair, and you know that you're going horizontally, so you're starting right at the origin point, or that 0, 0, and you're moving 2 spaces on the x-axis. Let's highlight that with some yellow here, starting at the origin, and you're going 2 spaces. Then our y-coordinate tells us that we need to go 10 up, and so now we follow our ordered pair from 2, and we go all the way up to 10, and we should be ending right around here. So rather than draw this nice little line and make these lines across, I'm just going to put one dot at 2, 10 on my graph, and now I have my ordered pair graphed. Since my ordered pair is now graphed, I have an idea of what this 2, 10 represents. It means that, especially on this graph, I can read what's exactly happening. It takes me 2 minutes to make $10. So at 2 minutes, I'm making $10. I have 2 pieces of information. The only spot that could possibly be on this graph at 210 is that location there. My ordered pair is graphed. So in your notes, I just need you to have this graph, put a little dot there with this idea of 210, and have your x's and your y's labeled so you know exactly where things go. It's a little recap on ordered pairs, so let's continue with proportional graphs. We're graphing some word problems. I just have a little listen symbol up here, nothing you need to write in your notes, so let's kind of process our way through this. Here we are looking at this word problem, and we have James earns $5 an hour babysitting. Determine whether the amount of money James earns babysitting is proportional to the number of hours he babysits by graphing on a coordinate plane. Explain your reasoning in the work zone. This graphing on a coordinate plane means you're just going to put this information onto a graph. Before you graph things, I always make T-charts. T-charts help me radically trying to figure out what I need to graph. So here I have dollars that James is earning. That is the first thing I'm looking at here. And then the second thing I need to know is number of hours that he is babysitting. So I'm going to put an H for hours there. And so now I know that he's making $5 every 1 hour, so that in the first hour he's making $1. In the second hour he is making $10. And in the third hour he is making $15. This is me just skip counting by 5s, knowing that he's making $5 every single hour. So now let's graph our information. We have a ordered pair just written vertically here. So now I have, and now if I read this graph, I have time on the x, meaning that my hours will be my x, and my dollars will be my y. That is a sloppy y. It looks like an x. Let's kind of change that up if I'm able to. Let's rewrite it. Y, nice and clear. There we go, perfect. So now I'm graphing, and I go 1 every 1 hour. Every 1 hour I make $5, so I'm going to put my dot right about there. And then on the second hour I make $10, so I'm putting my dot here. And on the third hour I make 15, and so I am up here. Now you notice me on those odd numbers on 5 and on 15, my y-axis doesn't have that information on there, which is totally okay. My data doesn't fit on my actual line, so I make it fit within the spaces. 5 is halfway between 4 and 6. 15 is halfway between 14 and 16. Therefore, I know my graph is correct. Here we have a proportional graph, and so now I'm going to connect them because I want to know all those times in between. how much money I would make. Notice my sloppy little graph here. Ideally, you'd want those dots connected, but we're going a little fast here just to give us an example. Always connect your lines if we're working through this idea of continuity. We can know that James can work for only a half hour, so we should be able to read his graph at that point. He can work for an hour and a half. He should have some data there. That's why we connect our lines. We're graphing our word problems. Moving on. So now we just need to know what makes a proportional relationship. There's 3 things we can look for. 2 of them are one or the other, whether you have a graph or you have a table, and then the third thing is only if you have a graph. So let's double check what makes a relationship proportional. You are writing this stuff down. I have 3 things for you. You're going to jot down some examples in your notes as well. Those will go really quick, and we're almost through our proportional graphing. First thing that you have constant inner rainbows. You look at this relationship, days and weeks. In 1 week, 7 days. 2 weeks, 14 days, 3 weeks, 21 days, 4 weeks, 28 days. This is common calendar stuff. What we can see here is that in between there, I'm taking my weeks, multiplying by 7 to get to the number of days. 2 times 7 is 14. 3 times 7 is 21. 4 times 7 is 28. Every time I'm multiplying by the same exact number. I'm taking weeks times days in order to equal, weeks times 7 in order to equal days. Because this 7 is constant all the way throughout, I have the same inner rainbow inside my relationship, and that makes my graph proportional. So if your information, and I said graph, I meant table, but this can become a graph, as long as you have constant inner rainbows, your relationship is proportional. That is number 1. Number 2 says if the graph makes a straight line. So if you're given a graph or you have to graph, if the graph makes a straight line, you're on your way to becoming proportional. You're not guaranteed proportional, but if your graph forms a straight line, just like this one does, we have an idea that it may be proportional. We would double check to see if we have those inner rainbows, if we have a table, otherwise we're going to look to rule 3. But just as a side note, if I have a graph that looks like this, it makes 2 straight lines. Unfortunately, that is not 1 straight line in total. This graph is not proportional. So I'm going to make a nice little X out, not proportional, that graph. This graph, however, definitely proportional. Makes a straight line, plus we can see that we're going to have those inner rainbows if we were to table that out. But as long as your graph makes a straight line, you're on the right page to having a proportional relationship. So 2 things so far: constant inner rainbows, graphs make straight lines. Stop if you need to, otherwise pick me up as soon as you're done so we can finish our 3rd reason what makes relationships proportional. The final thing, the graph must begin at 0, 0. If you don't have a table, or if you only have a table, then you might need to graph this. But if your graph begins at 0, 0, just like this one does, that makes it, guarantees that it is proportional. So if your graph makes a straight line and it begins at 0, 0, you got yourself a proportional graph. I'm going to draw a line, and I'd like you to do this in your notes as well. Draw a line between number 1 and number 2, and then that kind of segments these, that if we only have a graph, we're looking at these 2 rules. Must be a straight line, must begin at 0, 0. If you only have a table, now we're looking for those inner rainbows. If you get a table, you can graph it. If you have a graph, you can make a table. You can use either strategies, but you must have both of these for a graph and only this one for a table. So those 3 things make graphs proportional. Constant inner rainbows, and if you have a graph, then got to make a straight line, and it has to begin at 0, 0. Let's look at a quick example. This one you're just listening to, this is a proportional relationship. We're going to look first at our table. We're going to see if we have those constant inner rainbows, and we're going to start actually at number 1 here, because if I look here, this doesn't help, the zeros don't help me at all, because 0 times anything is 0, so I don't know if I have that constant multiplier. So I'm going to start at 1 and go to 6. 1 times 6 equals 6. And then I go to 2 to 12. 2 times 6 equals 12. 3 times 6 equals 18. 4 times 6 equals 24. Since all of those 6's are the same number, I have my constant inner rainbows. I guarantee that this is proportional. If you didn't want to look at those inner rainbows, you can just graph it, and you can see that at 0, 0, 1, 6, 2, 12, 3, 18, 4, 24, I have a straight line starting at 0, 0, proportional graph, following our 3 rules. Let's take a look at a non-proportional example. You are just going to be listening to this one. I didn't put my symbol up there, but don't worry, don't include anything in your notes. This is just a quick example. Looking at this first table, I should be able to find my inner rainbows. And so right now, I'm just going to punch in my calculator, because 95 divided by 5, and I get 19. So I have a multiplier here of 19 5 times 19 is 95. So if 10 times 19 is 90, I'm on my way to becoming proportional. Unfortunately, it's not. This is 10 times 9 to get there, and then 85 divided by 15 gives me about 5.66 repeating. So now I know that my multiplier here is times 5 2/3 or 0.666 repeating. Since all these are different, this cannot be proportional. If we didn't want to look for those multipliers, we just look to the graph. I automatically know I'm not starting at 0, 0, I'm starting at 0, 100. Can't be proportional. It does make a straight line, but doesn't start at the origin or 0, 0, therefore not proportional. Awesome. As we continue. Finally, that's all I have for you. So now you're putting in the punchline of the day. This is the last piece that goes into your notes for today. Your joke for today is, why should you never play poker in the jungle? Why should you never play poker in the jungle? Well, it's because there are too many cheetahs in the jungle. Don't play poker, too many cheetahs. In your notes, get me that too many cheetahs written in there to show me that you watched this entire video. And with that, I will bid you adieu and say, adios, my friends. Happy proportional relationships, and I will see you Thursday. Bye-bye.